Sample point selection. Determining which sample to analyze is usually as iterative, uh, uh, iterative process based on several factors and input. Some of these factors include regulatory requirements, product quality, process conditions, control strategies, economic justifications, and more. Usually, the final selection is a compromise that may not be optimal for any one factor, but it is the overall best of the options under consideration. Too often, mistakes are made in existing processes when selections are based on a simple single guideline, like the final product or the intermediate sample that has been routinely taken to the lab. True, usually has relatively good data regarding the composition of sample, but it is the best sample to use the control the process continuously to make the best product and or manage the process safely and efficiently. Or it is the one that will just tell you that you have or have not made a good product. Both are useful information, but usually the latter is more effectively accomplished in in a laboratory environment. When you consider all the costs of procurement, engineering, installation, and maintenance, you rarely save enough money to justify installing process analyzer just to shut down or control waves. Since the onset of electronic age, because of the concern to keep us with ever increasing challenged by more sophisticated instru- instrumentation and control algorithms. Instrument engineers paid less and less attention to final control elements, even though all process control loops could not function without them. Final control elements may be the most important part of a control loop because they control process variables such as pressure, temperature, tank level, and so on. All these control functions involve the regulation of fluid flow in a system. The control valve. The control valve is the most versatile device able to do this. Thermodynamically, dynamically speaking, the moving element of a valve, may it be a plug, ball, or van, together with one or more air pieces, restrict the flow of fluid. This restriction causes the passing fluid to accelerate, converting potential energy into kinetic energy. The fluid exits the orifice into an open space in the valve housing, which causes the fluid to decelerate and create turbulence. This turbulence is turn create heat and at the same time reduce the flow rate or pressure. Unfortunately, this waste potential energy must part of a process is irreversible. The addition high pressure reduction in a valve can cause cavitation in liquids or substantial aerodynamic noise with gases. One just choose a special valve designed for those services. There are other types of final control elements such as speed control pumps and variable speed drivers. Speed control pumps, while more efficient when flow rates are fairly non for really constant, like the size range, materials choice, high pressure and temperature ratings, and wide flow range that control valve offer. Advertising claim duty better efficiency that valves cite as proof only the low power consumption of the variable speed motor and omit the high power consumption of the voltage or frequency converter that is needed. Similarly, variable speed drivers are mechanical devices that vary the speed between a motor and pump or a blower. These don't need an electric current converter because their speed is mechanically adjusted. Control waves have a number of advantages over speed control pump. They are available in a variety of material and size. They have a wider range ability, a guide to the automation body of knowledge. Third edition, range between maximum and minimum controllable flow, and they have better speed of response to make the reader familiar with at least some of the major type of control valve. The most important final control element. There here is a brief description. Valve types. There are two basic style of control valves: rotatory motion and linear motion. The valve shaft of rotatory motion valve rotates a vine or plug following the commands of a rotatory actuator. The valve stem of linear motion valve moves toward or away from the orifice driven by uh, reciprocating actuators. Ball valve and butterfly valve are both rotatory motion valves. A globe valve is a typical linear motion valve. Rotary motion valve are generally used in moderate to light duty service in size above 2 in 5 2 in 50 mm, whereas linear motion valves are commonly used for more severe duty service for the same pipe for the same pipe size. Rotary valves are smaller and lighter than linear motion valves, and are more economical in in cost, particularly in size above 3 in 80 mm. Globe valve are typically linear motion valve. They have less pressure recovery, high pressure recovery for FL that rotary valve, and therefore they have less noise and favor cavitation problems. And the penalty is that they have less CVKV per diameter compared to rotary types ball valves. When a ball valve is used as a control valve, it will be used usually have design modifications of improve performance. Instead of a full spherical ball, it will typically have a ball segment. This reduces the amount of seal contact, thus reducing the friction and allowing for more precise positioning. The leading edge of the ball segment may have a V-shaped groove to improve the control characteristic. A ball valve trim material is generally 300 series stainless steel. See figure 8.1.